Hi everyone. My name is Polly, and today I'll be going over some FRQs from the AP Chemistry exam 2024. So the first one I'll be going over today is question number 4, which is one of the shorter questions. And let's get started. So question 4 begins. Oh, right here. So I already kind of highlighted some key points, but let's go through it. Number 4. A student performs an experiment to determine the specific heat capacity of a metal. The student places a cube of the metal in boiling water so its temperature will be 100.0 degrees Celsius. The student then places the metal cube into a calorimeter that contains water and records the highest temperature of the water. A data table and the diagram of the thermometer are at the highest temperature are shown below. So the first question, part A, goes, what should the student report as the highest temperature of the water? So um, as you can see here, they kind of go by ones. So you'd have 31, 32, 33, 34, 35. And then we go to 36, 37, 38, and it's a little bit above 38, but not quite 39. And as you can see over here, they measure temperature um, to the tens place. That's what we're going to do as well. So I said 38.5 degrees because it's smack dab in the middle. Make sure you label your temperature. It's almost always going to be, actually, no. For this, it's Celsius, but could also be Kelvin, depending on the problem, such as gases and whatnot. Part B. A particle level representation of water molecules in the calorimeter before and after the metal cube was added is shown. The length of the arrows in the before diagram represents the speed of the water molecules in the system. In the after diagram, draw an arrow for each molecule to indicate how the speed of each of the molecules changes after the metal cube is added. So the metal cube, as you can see, is hotter and it's going into the water. So the water is going to heat up, right? Because the water is going to take in um, that heat. So I just made the arrows longer because they're moving faster. Letter C. Assuming that the metal transfers 2,940 joules of thermal energy to the water, calculate the specific heat of the metal in joules over grams times degrees Celsius. Okay, they were nice. They said they did it in units of joules, but they don't always do that. So just always keep an eye out because if they give you kilojoules, make sure you convert it back. That way it will cancel out with the joules over here. So I couldn't get the delta symbol for some reason to type out. So this is just your Q equals MK equation. So Q equals mass times specific heat times final times temperature change. So final minus initial. And we're solving for specific heat and we're solving for a specific heat of the metal. So make sure you just label that. Because this is at least straight from the College Board website. So this is exactly what they want you to do. So you do Q metal over the mass and the temperature change, and you can just go up here. You know that, well, this was given to us right here. We negate it, make it negative. And then you have the metal, which is over here, 98.1 degree or grams. And then your temperature change is, this was your initial, right? And oops. That's your initial and that's your final. And remember, we just said that the final was 38.5 degrees. So you plug that in and you should get 0.487 joules over grams times degrees Celsius. And notice I used 3 significant figures as is shown right here because this 0 is not significant because there's no decimal point after it. For letter D, it goes, in the second experiment, 2,940 joules of thermal energy is transferred from 98.1 grams of aluminum, which has a specific heat capacity of 0.897 joules over grams times degrees Celsius. Explain how the magnitude of the temperature change of the aluminum uh, compares with the magnitude of the temperature change of the metal in the original experiment. So obviously 0.897 is a bigger value than 0.487. And that just basically means that it takes a bit more energy in order for there to be a temperature change in aluminum versus this metal. Same thing, you can think of it as water, which is 4.18. You'll remember that from Regents. Water has a super high specific heat. So like, sorry, that's why it takes so long for water to heat up, like at the lake or something like that. So same kind of principle. That's even from earth science if you think about it. So I said the value of delta T of aluminum will be smaller because aluminum has a greater specific heat capacity, and that indicates that the same amount of thermal energy won't change the temperature of aluminum as much in comparison to the metal. And that's it. That's one of the short FRQs, and hope that was helpful.